Okay, guys, so we will be resuming our workshop session. Do you know leap days can be traced back to ancient times? To know more such interesting facts, I would like to invite Master Soumit Nayak to illuminate us about time and calendars. Over to you, Master Soumit.
Thank you, Palak. So now I'll be starting off with my presentation. So I'm Soumit Nayak, a third year student in Astronomy Club of Government College of Engineering, Nagpur. So my topic for today is calendar and time. Firstly, I will cover this is the first part. I'll cover calendar, and the second part will be time. So in the middle, I'll take a break where I will answer your questions, if any, and if not, then I'll proceed to the end, and then we'll look at it. So why did I choose this topic? Well, so my friends actually, like you can see Neil and Shantanu, they actually presented about relativity. So what they basically did was took a complex topic and made it simple. So I thought, why not do the opposite? I'll take a difficult topic, I'll take a simple topic and make it more difficult. So with that, I thought I should take this because it's not just I'm making a simple topic difficult, but I also want to tell you what the complexities and the things that are involved when making these methods like of timekeeping and date keeping. So without any further ado, let's begin. Oh, okay, my voice is a bit low. Is it better now? Ashutosh, can you confirm?
Suma, your voice is perfectly fine.
Okay, fine. Okay. Yeah, so without any further ado, I'll just start with the presentation. Okay. So what exactly is a calendar? So what is the first thing that comes in your mind when you hear the word calendar? You think of something like this picture over here, where there are dates, there are months, there are days, and where sometimes they're in red, which indicate they're the holidays or they're Sundays. So you actually rejoice when there's a vacation and stuff. What exactly is a calendar is, it is as you can, this is a dictionary definition, is a system of organizing days by giving names to periods of time, typically days, weeks, months, and years. And calendar is not something that is particularly new. Our ancestors actually used calendars since way back, and some of the most prominent calendars are like the Roman calendar, Julian calendar, Hindu calendar is there, there's Islamic calendar, there's the Hebrew calendar of the Jews, and many more. There's even Mayan calendar. Many of you may have heard of it. So why did calendars actually come into existence is the first question. So our ancestors, I don't know what is happening. Our ancestors were, I don't know what's happening. So our ancestors were actually nomads. So they actually used to travel from place to place, and depending upon the season, depending upon the stars, they could actually know which season it's going to come and which is the current season. And because of that, as you know, in winters there are like plantation, there's a lack of vegetation around the near the poles, so they have to migrate to warmer regions so that they can actually get food. So that was the reason why ancestors used to look at the stars and used to ascertain that winter is approaching or there's gonna be summer, so we should move to warmer parts, colder parts, regarding to the season. So because of that, it was important. But eventually, we started settling in civilizations. Because of civilizations, we got agriculture. Agriculture. And because of agriculture, we started living in a single place. And because of that, there was some important, with the use of calendar, we used to mark important days like the days of harvest. And until this day, we actually celebrate harvest festivals like Baisakhi and stuff. Baisakhi, there's Pongal, there's Onam. These are all harvest festivals. At this day, farmers used to harvest food, and till date we celebrate that fact. Yeah. So moving on to the next slide. So the one of the first calendars that was widely used was the Julian calendar, but the Julian calendar was actually a successor of the Roman calendar. It was a successor of the Roman calendar. So the Roman calendar was actually a lunisolar calendar. Um, sorry, lunisolar lunisolar calendar. So what it meant was that it used to like the days used to advance with the moon, but after like every few years, it used to they used to add a extra month. So basically, a lunar year is about 354 to 355 days. It varies from year to year. I don't know what happened. Is my voice audible?
Yes, yes, it is.
Okay. I don't know what happened. Suddenly my annotation system. Okay, so a lunar year is like 354 to 355 days. 355 days long, and a normal year is about 365 days. You must have known about it. So this creates a discrepancy of like 10 to 11 days. So what do we do with this? So basically, what the Romans did was after every 3 years, they added a something called a leap month, and it used to be inserted after February. Leap month, and it was inserted after February. After February, there was this leap month called the intercalary month. I don't know how to write this. Intercalary. Intercalary month. So this was inserted after February. That brings the tradition of adding the leap day to the end of February actually. So what actually happened was designed this way, but it was actually very inconvenient because these leap months that you see are people. It was decided by some mathematicians, and it was more or less arbitrary. They used to just add it sometimes, they just did not add it some other time. So it was very confusing for the layman. So Julius Caesar, the people's hero, actually went to Egypt, and around this time, like um, around 50 BC or something, he ventured to Egypt and he saw beautiful pyramids and some beautiful temples and stuff. Most important thing, that is the Egyptian calendar. Egyptian, uh, the Egyptian calendar. So the Egyptian calendar was a solar calendar. So it was based upon periodical flooding of River Nile, which actually happened every 365 days. So because of this, the Egyptian civilization knew that a year is approximately 365 days. Because the seasons and all those repeat every 365 days, so the Egyptian people were sure that year is more or less 365 days long. So Julius Caesar saw that this calendar was far superior than his Roman calendar. So he decided to bring one of the mathematicians of Egyptian civilization, that is Sosigenes of Alexandria, with him back to Rome. And after coming back to Rome in 45 BC, in 46 BC, sorry, not 45, in 40 before 46 BC he came, and then what he did was he asked all the mathematicians in the Roman Empire, which also included the regions of Greece, to actually calculate how many days are in a year, and they actually came to a good conclusion of 365 point. I don't know what's happening with the annotations. I'm sorry for the annotations. So So it is actually 365.25 days. So they actually calculated that a year consisted of 365.25 days, which was a very good approximation to that time. But the Julian calendar was proposed. So it consisted of 12 months that we have now. We have these months until now, that is January to December, just the way they are. And every fourth year there is a leap year. Every fourth year we have a leap year, just like we have now. Like, so every fourth year we have a Feb 29, that is a leap day, which occurs in a leap year. So we have that system even until now. And so you may think if this Julian calendar, we have that system even now, but why do we not call it Julian calendar? Why do we call our calendar the Gregorian calendar? So good question. So I'll tell you about it in the next slide. So Gregorian calendar. So the calendar that we now use is called the Gregorian calendar. So the Julian calendar said that we have our length of day was 365 days and 6 hours, which is 0.25 days. So that, but it was actually not that, because there was slight I wouldn't say it as a calculation mistake. I think it was more in the sense of like they did not have the capacity to calculate more precisely. So the more precise calculation would be this number. Yeah, it is a pretty long. So what is the problem with having the Julian calendar? So the problem with having the Julian calendar is every 128 years. So it is over here. Every 128 years, we see that the day shifts by it shifts by a day. That is called a calendar drift. So every 128 years, we see a drift of one day, and no human lives until 128 years. Like I honestly don't think any human lives that long. But over the course of time, over the course of centuries or millennia, it actually starts to add up. And by the year 1582, this was the year Gregorian calendar was proposed. People started to notice, and so that was brought to the Pope. And the Pope was called Gregory, hence the name Gregorian calendar. So what the Pope did was he actually accumulated all his scientists and all the mathematicians of the Pope friendly countries, and decided to calculate how many number of days we have in a year. And they came to a better approximation of 365.24 and 25 days, which is better than the Julian estimate of 365.25, but it is not enough. So what is the difference that we have in the Gregorian calendar that we don't have in the Julian calendar is, for Julian calendar, every fourth year is a leap year, but for Gregorian calendar, there is a clause. The clause is that if divisible by 100, it should also be divisible by 400 for it to be leap year. So what it actually means is the year 1600 would be a leap year, perfectly fine, but 1700 would not be a leap year because it is a multiple of 100. 1700 is a multiple of 100. You can see by the two zeros, but 1700 is not divisible by 400. So it is not a leap year. So similarly, 1800 was not a leap year, and 1900 was not a leap year, and 2000, that is my birth year, was a leap year. So that is the difference that the Gregorian calendar brings to us. So the most of the Pope friendly countries adopted it in October 1582. This is how the calendar would have looked like. You can see the date was 4th, and then directly it was 15 to compensate for the calendar shift. But some country like the UK and its colonies, so United States was a colony in 1752, they were not so Pope friendly, so they adopted it like in 1752, which is like 170 years after the most of the world. So they had a little longer shift. So this was the reason why there are some drifts in those. This is how the calendar would have looked like. And some places, like some people's birth dates, they have two birth dates in some cases. Like there's a famous case of George Washington, who has two birthdays in his birth certificate. One is the Julian calendar date, one is the Gregorian calendar date. So is the Gregorian calendar perfect? No, the Julian calendar had a drift every 128 years, but for the Gregorian calendar, the drift is much bigger. That is 3,216 years, which is pretty superior as compared to the Julian calendar, but still not perfect. And do we have any means to make it even better? Currently, I think there are some people who are still trying to get new calendar into effect, which would make our existing calendar even more efficient. But as of right now, we don't. It's not like we don't clearly know if that will be implemented or not. So the Gregorian calendar is now adopted by every country in the world, and so yeah, that's the Gregorian calendar, and here are some interesting videos and websites that you can refer to. So this video in YouTube, it talks about some calendars. I think it talks about the Hebrew calendar, Islamic calendar, and some other calendars. This is the website. You can see some interesting things that happened because of the Julian calendar, the change from the Julian to Gregorian calendar. So one such is like the the country of Sweden actually had a date of 30 February. So I think this is a pretty interesting. It's a pretty interesting. You can see other calendars as well, like the Hindu calendar and the Buddhist calendar, and etc. And this is the video of a mathematician called Matt Parker, who actually, as I told you, like the Gregorian calendar has a shift of one day every 3,216 years. So he tries to make an even better system. He proposes some. You can have a look at it. And so now half of the session is done. The calendar part is done. So now I'll be moving to some time part. So if there are any questions, I'll try to answer it. Okay. I just saw that message now, Shiv Sankar. That voice is ask in the chat box, or if you can unmute, then you. So I suppose there are questions right now to the next part. Okay, okay. So that's usual. Vikram Sambat calendar. I don't know much about the Vikram Sambat calendar. I know that it is a lunisolar calendar. It is a lunisolar, like the Roman calendar, it is a lunisolar calendar. And we have the concept of leap months even in the Bikram Sambat calendar. But I don't know about into the huge details on how they actually calculate the days and stuff. So if you want to actually read about it, you can actually read the Wikipedia article. I don't have in-depth knowledge about it. So Bikram Sambat calendar is actually the Hindu calendar that is used in for Hindu festivals like Diwali, Holi, etc. Okay. So I'd like to assume there are no more questions as of now. So I'll move to the latter part of the presentation if you don't mind. Yeah, sure. Okay. So what? So now we are moving to the time part. So yeah. So the in the calendar section, I told you like everyone says there is a different X number of days. Someone says no, there is not X number of days. There's Y number of days. So what exactly does a day mean? So is it a uh, a day is approximately the period of time during which the Earth completes one rotation around its axis, or is it B? A day is the length of time which elapses between the sun reaching its highest point in the sky two consecutive times. So I'll try starting a poll if it is possible. Uh, which ones? So yeah, I've posted a poll. You can try answering that. What is your opinion on what is a day? There's A and there's B. Okay. I see many people answering at it as A. Okay, I can see like a majority of the people are answering A. So I'll just close the poll. Yeah. Okay. So there are like last 15 seconds to answer the poll, and after that it will be closed. So if you want to answer now. Okay. So majority of the people, almost like three times the number that have the three times the number of people have answered as A. So what exactly is the answer? Let's have a look at it. So both are actually right. So the A option is called the sidereal day, while the option B is called the solar day. So this is the Earth's rotating and it's revolving as well. So as it completes one whole that face the sun doesn't face it right now. So it actually has to rotate a little bit more. This is called a solar day. So that it's the same time because the sidereal rotation, that is 360-degree rotation, that is 23 hours and 56 minutes long, while a solar day is slightly longer than 23 hours 50. So a sidereal day is 23 hours and 50 minutes long, and the solar day actually varies. So this actually shows 24 hours for the sake of like simplification, but it actually varies. So what actually happens is, as Shantanu has already addressed in his presentation, that the Earth actually revolves in an elliptical orbit. So this is the sun, this is the Earth. So because of the sun should be bigger, sorry, be bigger. Um, So I know it's not size accurate, but this is the best I could do. Yeah. So let's assume, so because as it's an elliptical orbit, so when it's closer to the sun, it actually revolves faster. As it revolves faster, it has to rotate a little bit more to compensate for the revolution speed. So during that time, the length of the day exceeds 24. It is on the slower part of the orbit, so it actually is little less than 24 hours. It is of course more than 23 hours and 56 minutes. That's a sidereal, which is the sidereal period. But it is actually not exactly 24 hours. Sometimes it's more, sometimes less. So 24 hours is what we call a mean solar day. So that is the average of all the differences. I mean, the average of the length of the day in a year is 24 hours. So I'll tell you more about it in the next slide. So mean solar day. So the 24 hours that we have is called the mean solar day. So basically a solar time, so the sundial that many may know about the sundial actually shows what we call is a solar time. So you may know many ancient civilizations use sundial, and the water clock uh, that is which is also used by many civilizations shows something called relative time. So basically, what it means is sundial shows the solar time, and as it is 12 o'clock in the sundial, as 12 o'clock in a sundial is when in tropical regions your sundial doesn't have a shadow. The shadow is directly underneath it, so it doesn't have a shadow. But when it is in, let's say, it's not, the sun isn't directly over you. Let's say in countries which are more closer to the poles, your shadow actually points directly to the pole, that is the north pole or the south pole. It points directly towards it. That's when we have something called the ap, apparent noon. This is the time we call the apparent noon. So apparent noon. This is the time when we call the apparent noon, when either your shadow isn't visible, it's either directly below you, or your shadow points directly towards one of the poles. That is when we call it an apparent moon. So that is the time that the sundial shows. So the UT1 time, which is stated over here. So what it does is actually it's a bunch of telescopes which actually look at distant quasars, which tell you the time. So it acts like a modern day sundial. While the UTC time, which is I don't know if I've put it in here. There's a UTC time, which actually acts like a modern day water clock, except it is operated by atom. It is operated by atomic clocks. So there's atomic clocks. The atomic clocks are the one of the most accurate time. You know, it detects absolute time. So there's UTC time, which is monitored by the atomic clocks, and there's the UT1 time, which is monitored by the distant quasars and pulsars. So distant quasars, which tell you what the time is like a relative. So this is the UT1 time. So these times have a difference in less than 0.9 seconds. Why is this important? I'll tell you later. So just remember this: the UTC time is actually maintained by atomic clocks, while the UT1 time is maintained by distant quasars and other celestial objects. Um, so what is this graph? So this is the graph between so if you keep sundial for like let's say a year, so you will notice that it doesn't always point at the right time. Why doesn't it point at the right time? Because of various factors about the Earth's revolution around the sun, and the fact that the Earth revolves in a elliptical orbit. So the length of the day actually varies. Not the length of the day, the length of the time at which the sun is at the highest point actually varies from time to time. So this graph actually tells us about it. So this is the point in, let's say, I think it's about 300 days. So 300 days from the start of the year, you will see that it actually there's a difference in about 17 minutes from the base day. So they have taken the base at these days they have taken the base. That is when there's literally zero difference. So at 12 o'clock, your sundial will point exactly at the exactly at the north pole. So basically, your time is actually accurate. So and so because of sun, you can actually have like let's say because sun actually there's a difference between let's say sunrise in Mumbai and there's a difference between sunrise in Pune. So if if towns actually started maintaining their own time, it would create a lot of chaos because Mumbai and Pune are like roughly around 200 kilometers away. So there would be a difference in time, which would be fairly significant, which would create a lot of problems. So earlier there were places which actually maintained their own time zones. The towns had their own time zones, but nowadays, as we move to modern era, we have something called what time zone does is so a particular region in the world adopts a single time zone and those use it. So let's say for India, even though the west end and the east end are pretty far apart, they should fall in like two separate time zones if you look at it. So there's this time zone and this is let's say number two. Number one, India should fall in two separate time zones, but it actually maintains one single time zone. So which is called the IST, which is actually UTC. The UTC time actually is the Greenwich Meridian time plus 5 hours and 30 minutes. where with uh, yeah, so I will tell you what DSTs are afterwards. So this is actually the time zone that India maintains. So the eastern part of India, which is northeast, like let's say Arunachal Pradesh, the sun rises 2 hours before it does in, let's say, Gujarat, which is the western end. So because of that, there were like earlier, like there should have been problems because let's say you're calling your relative lived in this side and you lived in this side, so you call them up and you actually converse and you find out that you're living in different, it could be rather confusing. So India opted for a single time zone, same with China, but some other countries, let's say Russia, they have like so many time zones, so from here to here. And even America, like all the way from Alaska to this place doesn't belong in America, this place, yeah, so there are so many time zones from Alaska to Eastern Standard Time, I reckon. So they have some countries have multiple time zones, but some countries actually maintain same time zone. So China and India are one of the few examples which actually maintain the same time zone, regardless of how big they are. And though it is somewhat, let's say, so there are some northeastern states which actually have put up an argument that it makes them inefficient because the sun actually rises up earlier, so they actually start the livelihood earlier, but because there are some activities which are like, let's say, for the share market opens all over India at the same time. So because of some issues, they are facing some issues for having a same time zone as the rest of India. So they are actually demanding for like two time zones. Historically, India actually had two time zones. One was called the Bombay time zone in the western end, and the Calcutta time zone in the eastern end. But nowadays we just have a single time zone. So now coming back to what is DST. So basically, if you go northern towards the poles, not northern, towards the poles, you'll see that during the winters, our sun actually sets pretty early. It's a common phenomena. Where India is a fairly tropical country, so we don't actually have a huge difference. It is a significant difference for us to notice, but it's not a huge difference. But in the northern places, let's say in London over here, London, so the sun sets as early as, I don't know exactly, so 4 to 5 p.m. It sets pretty early. And so what exactly does DST do is, um, so what exactly does DST do is, it actually in the spring, uh, yeah, so in the spring what they do is they advance the clocks by an hour. So actually, when it's spring, like right now, they actually have their time which is 1 hour forward than normal time. So let's say it should have been 10 o'clock in normal time, but they actually have the time as 11. So what they do is they advance the clock by 1 hour in the spring time. And when it's autumn, that is autumn. During autumn, they actually revert back to the old time. So 10 o'clock is actually 10 o'clock. So what it does is it actually gives them an additional hour of daylight, which is actually beneficial for, let's say, children who are actually traveling to school in, let's say, in afternoon when they're coming back from home. It is not, it is not dark, and the traffic incidents with people coming back from office, etc. So this actually helps them. So for the countries towards the poles, it actually helps them. So the map below is actually the blue parts are the northern hemisphere, from the northern hemisphere, and the orange parts are from the southern hemisphere, which actually follow DST. So these places actually follow DST. As you can see, these are region divided, not divided by country. For, let's say, Australia, the whole of Australia doesn't follow DST. Only this particular section follows DST. Same with Canada. Whole of Canada doesn't follow. These two regions don't follow. The rest of the country follows DST. And the light gray ones, like India, China, those actually followed DST in the past, but now they don't. And the dark grayed ones have never followed DST since their existence. So India actually followed DST when there was the British rule in India, of course. And after that, there was an instance, if I am not wrong, during the war, we actually implemented DST across the country. We'll move to the next slide. So this is the fun with DST. So one of the fun things that have happened with me when I actually discovered what DST was. So this was a message from a friend. So I just look at the time. So the first time stamp is at 6:23, which is for me. So this is the time at which I received the message, first message, and this is the time when I received the second message. So there's nothing wrong with it. So that's like 39 minutes difference, approximately 39 minutes difference between the first message and the second message. But for him, if you look at the times, so 2:03 and 6:23. So these are like, let's say this is the time zone difference between us. This is equal. So 6:23 and 2:53. But if you look at 7:12 and 2:31, so after 2:53, he sent the next message at 2:31, which is, if you look at it, which is he traveled back in time. So did he actually travel back in time? Well, actually, no, he did not travel back in time. As my friend Neil and Shantanu have already said that you cannot travel back in time. It's not part of a laws of physics. So actually what happened was at 3 a.m. for him, like 3 a.m. for him, actually DST started, what happened was it changed season from it was autumn, I think, for him. So as soon as it was 3 a.m., so it actually reverted back to normal time. So what actually happened was after 3 p.m. 3 a.m. It wasn't 3 a.m. It became 2 a.m. Uh, 2 a.m. Yeah. So after 2 a.m. it became after at what point it should have been 3 a.m. It actually became 2 a.m. And after that, after 31 minutes, he sent the second message. So that is the reason why you can see he sent the second message at a before time. So that was the reason why he said, look at the time. And I did not understand because for me it was totally normal, but for him it was not normal. And yeah, this was a fun conversation I had with him. So coming on to the last topic for the day, that is the leap second. So what exactly is leap seconds? We have heard of leap days, leap years, but what exactly is leap second? So I may have told you something about UTC time, which is maintained by, let's say, atomic clocks. Atomic clocks and UT1 time, which is maintained by observatories by looking at distant quasars. So they don't have, so the difference between them doesn't exceed 0.9 seconds. So what exactly happens is, first they actually calibrated with the UT time, they actually calibrated UT time with UTC time. But eventually what happened was we noticed that our planet is not rotating consistent, like at the same velocity consistently. So let's say this is Earth, and it should rotate like every 24 hours, right? At that's the mean time, but actually it actually has shifted a little bit. So because of this, a 24 hours should have like 86,400 seconds, but it actually has become a little bit slow over time because of various reasons. Sometimes it also becomes faster, but mostly it is it is becoming a little bit slower. It happens because of various reasons. So one of the main reasons is seismic activity, that is earthquakes and stuff, earthquakes, plate tectonics and stuff. And the next reason is one of the biggest reasons is actually man-made. So how exactly is it man-made? Man-made. So basically, humans have started building gigantic structures in the last century or so, and because of this actually changes the speed of rotation. So China actually has a dam called three. I think I'll just this dam. So Three Gorges Dam. So basically, this dam is actually so huge that it actually slows down the rotation speed of the Earth. So there's a committee called the IERS, which actually stands for International Earth Rotation and References Service. I don't know what it is called IERS. It should be called IERRSS. But yeah, that's not one of my concerns. So this actually maintains the difference between UTC and UT1. So because there is a difference that happens, a difference in every 1.5 to 2 years, we actually notice that this has actually UTC time is actually about 0.9 second. The difference is about 0.9 seconds. So what the committee does is actually adds a leap second. So normally it should have been 23, 50, 59, 59, and after that it should have been 0, 0, 0. But because of the implementation of the leap second, we actually get 23, 59, 60 rather than. So this is one of the instances when we actually saw DST leap second being implemented at December 31, 2016. This is actually the UTC time. So the Indian time would have been 5:30 60 for India. So this would have been the time at India when DST was implemented on December 31st, 2016. So DST, sorry, leap seconds, sorry, not DST, leap seconds. So this is the time when leap second was implemented in India in 2016, December 31. So leap second is actually a decently rare phenomena. The scientists actually announced it 6 months prior on two dates. It's either uh, so they either announce it on June 30 that they will implement a leap second in December 31st, or they announce it on December 30, December 31st, that they'll actually apply a leap second on June 30. So two times a year, the scientist concerned authority at IERS actually declare whether they will add a leap second to a clock or not. So there are actually some arguments uh, who say that leap second should not be implemented because it creates some problems. For example, the share market where every single second counts, and creating an additional second actually it actually creates a problem for the computers. So that would be very annoying. So our electronic gadgets actually maintain what the UTC time. That is the UTC actually you don't have to do anything. So if there's a leap second which gets implemented, the UTC will automatically make the changes within your device, and you wouldn't even notice. So if you want to actually like in June 30, we'll get the announcement whether December 31st, 2021 will actually be leap second or not, because we know that June 30 will not have a leap second. So you can wait until June 30 and see if December 31st is a leap second or not. So with that, this is one of the few interesting videos that I would recommend to you watching. These are the inspiration behind my presentation, and very thought out and much more educative video. So with that, I would like to thank you all for listening, and now I'll answer some questions. So are there any questions? I'll look at the chat box. Mm, I don't see any questions in the chat box. So does anyone want
Yeah,
to? Okay.
we have a private question. Why do we have 7 days a week?
That's 7 days a week. I think it's more or less a convention. It's not something that has any significance. It's more or less a convention that we took 7 days for a week, because like let's say they want like 365 was not divisible by anything. So for weeks, like it was divisible by 5, but 5 was too short, I guess, for them. So they decided 7 would be a good number. That's my only educated guess. Yeah, sorry.
One more question. How had Akbar invented the modern Bengali calendar?
I actually have no idea, Sarup. I don't know how I don't know about what Akbar did and what the Bengali calendar is, sadly. If you want to, you can actually check it out on the net. I'm sorry, I don't know about it. I never came across it while researching for this topic.
Very good afternoon.
Yeah, good afternoon.
I want to know about ये जो lunar calendar होता है इसमें 13 months मतलब अधिक मास भी एक सिस्टम होता है वो कैसे और
Yeah,
क्यों
yeah.
होता है?
I told you about the leap month, right? So yeah, so lunar month actually has 350 lunar year, sorry, lunar year actually has 354 to 355 days, and the solar calendar has 365 days. So as calendar is our Hindu calendar is a lunisolar calendar. So it actually looks at the lunar calendar and the solar calendar, and if there's some discrepancy over the years, it actually tries to solve it by adding an additional month. So because of that phenomena, we actually add an additional month because in 3 years we'll have a difference about 30 to 33 days. So because of
It depends on rotation
13th,
of
13th
moon.
month. No, it is because the revolution of moon around the earth is like 20 about 28 days, if I'm not wrong. So because of that, the lunar year is 354 to 355 days, and the solar year is 365 days. So it has a 10-day difference. So in 3 years it becomes 30 days. So because of 30 days, we want to make it normal. So we actually add a leap month.
Okay. Thank you.
Okay, yeah, no problem. So any more questions? I think you can
Your
unmute if you
presentation
have
is
any.
too good.
Yes.
Your presentation is too good.
Thanks a lot. Thanks a lot. That means a lot to me. I see Krishna is actually unmuted. Do you want to ask any doubt, Krishna? And same with ST Pomiru Savisara. Sorry if I misspelled your name. Thank you, Prajwal. I wanted that was my idea behind it. I wanted to have a unique presentation. Thanks a lot, Prajwal. It means a lot. So I think there are no more doubts today. So I would ask Palak to take the mic. Thanks everyone for listening.
Yes, thank you so much, Master Soumit Nayak, for sharing your knowledge with us. Now, I would like to thank everyone for gracing today's workshop with your presence. We have reached at the end of day one of STARGAZE. Once again, I thank you everyone for your constant support. I, on behalf of Astronomy Club of Government College of Engineering, Nagpur, end today's session here. We will resume our workshop tomorrow at 1 p.m.